Okay, so let's go ahead and take a look at this lesson. So this lesson is writing the equation of the tangent and the normal line. So first thing we start off with is definition of a secant line. A secant line is just a line that connects 2 points together. Okay, so we have found equations of secant lines, like forever. You find the slope, you use point slope form to write the equation. Tangent line just touches the curve at 1 point. Finding the equation of the tangent line, find the slope, use point slope form, and then I would transform it to any other form after you look at multiple choice solutions. But if it's just a free response, you can just leave it in point slope form, which is 1,000 times easier. Normal line is perpendicular to the tangent line, so that means that you have to find the tangent line slope. Then you have to take the opposite reciprocal of it, which is there, and then you use point slope form. Yay. And then linearization, you're just what we call linearizing the function. So essentially what ends up happening is when it says find the linearization, they're really just asking for the equation of the tangent line. They ask it in basically point slope form, where they've moved that f of a to the other side. Okay. So now let's look equation of the tangent of the normal line. So I want first the derivative. So that is 9x squared. I want the derivative at 2. So 9 times 2 squared, which is 36. So that's the slope of the tangent line. So now y minus y1 is equal to the slope of the tangent line times x minus 2, which is your x1. And this is the equation of the tangent line. You take the opposite reciprocal of 36, and you write the same thing again. So opposite reciprocal means that make it negative if it's positive, or if it's negative, make it positive. So vice versa. Positive becomes negative, negative becomes positive. And then you just flip the fraction. So 36 was in the numerator, 36 basically over 1. And then so it becomes 1 over 36. And this is the normal line. Okay. So now f prime of theta, not x. So that's 4 cosine of theta minus 1. So f prime of 0, 4 cosine of 0 minus 1. Cosine of 0 is 1, so this is 3. So then y minus 0 is equal to 3 times x minus 0, because we're centered at 0, 0. So y is equal to 3x. That's the tangent line. And then the normal line is negative 1/3 x. Oh, I guess we should use theta, because that was the original independent variable. We shouldn't change them. Okay. Linear approximation means to find the equation of the tangent line. So first I need f prime of x, which is 3x squared minus 2. And then I need f prime at 2, which is 3 times 2 squared minus 2, which is 3 times 4 minus 2, which is 10. Now, I was given x is equal to 2. I need to find f of 2. So that's 2 cubed minus 2 times 2 plus 3. Again, remember, I can always use synthetic division. That's just not 1, not 2. 1, negative 2, nope. 1, just kidding. 0, negative 2, and 3. So I can always use synthetic division to figure this out. This is 1, 2, 2, 4, 2, 4, 7. Let me make sure I did that right. 2. Yeah. So now f of 2 is equal to 7. So my tangent line would have been y minus 7 is equal to 10x minus 2. My linearization, all I do is move the 7 to the other side. So that is my linearization equation. And then I want to use that to find f of 2.1. So f of 2.1 is approximately equal to, when I plug in 2.1 into my equation here. So now what ends up happening is I've plugged in a decimal into my equation of the tangent line. So I get f of 2.1 is approximately equal to okay, so my f of 2.1 is approximately equal to 28. And if I were to do this by plugging it in, I would have gotten, let's see, wait, hold on. I made an arithmetic mistake. This is not 2.1. I was like, I keep pausing because it looked funny. When I plug in 2.1 in for my x, it's 2.1. I was like, I knew that something was wrong. 2.1 minus 2. So that would have given me a 0.1. So then this is f of 2.1 is approximately 7 plus 10 times 0.1. Oh my goodness. So f of 2.1 is approximately 8. So now if I were to actually plug this in to a calculator, and I would have done 2.1 times 2.1 times 2.1, I would have gotten 9.261 minus 2 times 2.1, which is 4.2, plus 3. So 9.261 minus 4.2 plus 3 is 8.061. So what linearization does actually is it, when it linearizes the function, what it does is it gets you close to what the original value would be when you plug it in. Now, do I want to do linear approximations with polynomials? No. I want to do something where I'm not given the equation, so I'm not given f of x, or I'm not given anything really nice like trig functions, logarithmic functions, and we don't have calculators to give you approximations. Okay, so that is the reason why we do it. All right, so now values of vertical and horizontal tangent lines. So first I need to find a derivative, and then we'll define some things. So 3x plus 5 times 7 minus 7x minus 4 times 3, all divided by 3x plus 5, the quantity squared. Okay, so I keep wanting to scroll up, but it doesn't do it that way in GoodNotes. Okay, so 21x plus 35 minus 21x plus 12, all divided by 3x plus 5, the quantity squared. So I get y prime is equal to 47 over 3x plus 5, the quantity squared. Okay, so whatever is in the numerator is my horizontal tangent when I set it equal to 0 and solve. But 47 doesn't have an x next to it, so there's no horizontal tangent because I can't set the numerator equal to 0 and solve for x. But my denominator is where my vertical tangent is. And I set that equal to 0. And so at x is equal to what? Negative 5/3 is the vertical tangent. To the graph. So that's how you find horizontal and vertical tangents. Horizontal tangents, you set the numerator equal to 0. Vertical tangents, you set the denominator equal to 0. All right, so now we're at the check for understanding point. Go ahead and pause the video, do these on your own, and then see if you get the same answer that I do. Okay, so we're back. This is 2x to the negative 3/4 power. So I want to find the derivative. So f prime of x is equal to 2 times negative 3/4 x to the negative 7/4. And so I was like, my phone's about to go off because this is when I get all my emails. Let's see. Negative 3/2 x to the negative 7/4. So I want negative 3 over 2x to the 7/4. And I want to do this at x is equal to 1. Which is basically just 3/2. So negative 3/2. So that's the slope of the tangent line. So tangent line is y minus 2 is equal to negative 3/2 x minus 1. My normal line, opposite reciprocal slope, but the same coordinate. So y minus 2 is equal to 2/3. Be positive and flip the fraction. X minus 1. What are my values of my horizontal and vertical tangents? So f prime of x. And I probably wouldn't split these up because I need them to be with one numerator and one denominator. So the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So now f prime of x, 40x squared minus 15x minus 20x squared plus 15x minus 35. And this is all divided by 25x squared. So f prime of x is equal to 20x squared minus 35 all over 25x squared. So when I take 20x squared minus 35 and I set it equal to 0, this is my horizontal tangent. So the x coordinates of the horizontal tangent. And then when I set 25x squared equal to 0, this is my vertical tangent. So now 20x squared is equal to 35. So x squared is equal to 35 over 20. So x squared is equal to 7 over 4. So x is equal to plus or minus root 7 over 4, which x is equal to plus or minus root 7 over 2. And then this will just be x is equal to 0. Okay, so that is it for your check for understanding. And that is it for this lesson.